Welcome to the Math Record. Today we'll be introducing the concept of polar. This video will cover part 1 of chapter 7 in our Precalculus class. In this video, we will learn how to graph polar coordinates and make conversions. So what is a polar coordinate? A polar coordinate is just like an XY coordinate, but now it's represented by a length and an angle. So let's usually when you write coordinates, you write the x coordinate and the y coordinate, right? So it's, let's say in this case 3, 4. So you make a plane and you have like 1, 2, 3, 1, 2, 3, 4, right? So this is 1, 2, 3, 1, 2, 3, 4. And now you're gonna graph 3 to the right and then 4 up. So you're gonna graph like a point like right there. So you have 3, 4. And that's how you write it in what you refer to as the rectangular plane. But it kind of, because if you make a shape, it kind of basically looks like a rectangle. So it kind of like uses lines. I don't know why they really named it that, but basically. So the different way to name it is now we're going to have to use polar. Polar. So basically, instead of using the x and y, which is right here, so you make the x and you make the y to get to the point. Now we're going to use something called the length and the angle. So now we have the line that we made from the x and the y. And then we're going to make another line from the origin 0, 0 to the point 3, 4. And now we're going to use the angle right here. This is usually referred to as, it's basically like a 0 with a line in it. It's called theta. Theta is just a general term to represent like an angle. So it's just a Greek symbol, like math all the time. So they use a bunch of Greek symbols. And then we have something called the length, which is referred to as the radius. Because this is kind of like a circle, kind of. Anything time they use length, they use like a radius, but it's kind of like similar to a circle. So what we're gonna do is that instead of using x and y, we're gonna use the radius and theta. Because if you're using trigonometry, basically, you could use the radius, which is the hypotenuse, times theta to get a bunch of these side lengths. So you already get 3 and 4, basically. If you're using like the angle and the side length. So basically, what you're gonna do is that instead of writing it in 3, 4, so x coordinate and the y coordinate, now you're gonna write it in the radius and theta. So that's basically how you're gonna write it now. So the radius, you can see it kind of just looks like the hypotenuse. So you have 3 x the x coordinate squared plus the y squared, which is 4, and then you square root it. You get 5. So the radius is 5, and then you just have to find theta. So usually you kind of use your calculator for that. So let's just, we'll be covering trig in a different kind of topic class. So for now, if you don't know what it is, just kind of like use your calculator. So tangent of theta is the same thing as saying this is y and this is x, right? It's equal to y over x. So tangent of theta is basically 4 divided by 3. So when is tangent of theta 4 divided by 3? So this gets you 50. Theta would be 53 degrees, basically. Because you put tangent of 53, you get about 1.333 repeating, basically. So we're going to use theta as 53 degrees. So that is a really close approximation, but it's not the exact, but it's gonna work for now. So yeah, something like 53 degrees. So that's basically how you're gonna write it. 3/4 would be the same thing as 553 degrees. This is the radius and the angle measure. It's always the angle measure made by that line. So if you have something like a point like right here, like say this is -2, 5 or something, then you make a triangle in this side, and you have a right angle right here. Sorry, the picture looks bad. Okay, you have a right triangle right here. So you have 2 here, 5 here, and now you just find theta. Theta is always going to be positive, basically, right here. So what we're going to have is tangent of theta is equal to 5 over 2. So then when its tangent of theta is equal to like 5 or 2, that's when theta is 68 degrees. So you don't write like uh like 112. Like this side length would be 112, but you're not gonna write 112 basically because you're gonna write 68 degrees because you want this angle. I mean, sorry, yeah, you're gonna write 112 degrees. You're not gonna write 68 because 68 is right here, and you want this angle, so you have 112 degrees. So you don't want to write the 68 because you want from this side to this side, basically. So imagine like you have a line right here, but then you keep moving this over until you get right there, and then you basically get that angle. So you get a line like this. You get that angle, which is 112 degrees. Because this side over here is 68. Okay? Sorry about the bad pictures, but basically that's how I would think of it. And then you kind of write the radius. The radius of 2, 5 is 2 squared plus 5 squared, which is, negative 2 squared plus 5 squared. And then that's just like 4 plus 25, which is 29, and that's square root 29. You usually just write square root 29 and you won't simplify it. But if you want to simplify it, like the question asks you to, you can just round off and say it's like 5.4 or something. It will ask you like how many decimal places. So if it wants you to round to a tenth, just write 5.4. You know, round to the like the hundreds, you get like 5.39, or you round to thousands is like five. Sorry, I'm running out of room. 5.385. So basically, that's how you're gonna do it. So that's what is a polar coordinate. It's basically using the radius, and so a polar coordinate is basically using the radius and the theta instead of using the x and the y. So the rectangular, I'll just write r is rectangular. It represents by x and y. Uh, the the polar, which I'll say is p, is represent r and theta, which is just basically the same thing as r, where r is x squared plus y squared, and theta is equal to the tangent of theta is equal to y over x, basically. So that's the introduction to polar coordinates. And now, another property about polar coordinates is that polar coordinates have multiple ways to say about them. So let's take, for example, something like 60 degrees, right? There are multiple ways to actually write this. So what a polar graph will look like is that it's kind of look like this, and it has multiple circles. Sorry, my handwriting, my drawing is bad. And then make this longer. Okay. There's just a bunch of circles. Okay. So how you will read this is that basically the line, the circles will represent the radius. So all this is this is radius 1, this is radius 2, this is radius 3, this is radius 4, and then you keep going as radius 5, radius 6, radius 7, right, etc. Sorry, that doesn't look like a 3. That's a 4. So this line is radius. This circle is radius 4, and then you're gonna basically the line. If you just ignore the circles and you see the two lines, right? Basically, it's the same thing as using the plane. So you're just gonna make like angle radius. So to graph this point, basically you're gonna be radius 2. So you have right here, right? You start radius 2 because you always start at like over here in the line. So if it's radius 3, start here. Radius 4, start here. Radius 1 starts here. So you have 2, and you have to go 60 degrees. So it's 2, follow the circle, and you have to put it like right here. And then because right here at the line, like the diagram was some, like at that circle would be right here, that point. I'm sorry. So this triangle, and that would be 60 degrees. I mean, I just don't have space, so that's why I'm writing it like that. So that would be 60 degrees, right? Basically. So there's actually multiple ways of actually like writing this. So like you could write it as 2 2 comma 420 degrees, or 2 comma 300 negative 300. Sorry, that doesn't look like 400. What 420 degrees is, and 2 over negative 300 degrees. Because imagine you start at that point, right? You have 2, and then you go negative 300, which is going around the circle. So you're going this way. So you get negative, this is negative 90, negative 180, negative 270, and then you go a negative like 1 more 30, which makes more sense. So it's the exact same point, like right there, exactly the same point. Or you have 420 degrees, because you know how a circle is 360 degrees is? So you start from here, and you go like this direction, and you kind of make one complete circle, because that's 360 degrees is, plus that 60 degrees. So that's basically the one way to write it. Another way to do this is basically negative 2 degrees, and then you're basically gonna go 240 degrees, or you had negative 2, and then you have negative 120 degrees. So basically, instead of saying 2 is here, what you do is that you go to the other side, because this is also 1, this is also 2, this is 3, and this is 4. But this is on the other side, so basically this is gotta be negative 2. So you're gonna start here, right? And then you gotta go 240 degrees. So that's 90, that's 180, so you have to go 60 here. So it's the exact same point, right? Or you could go 120 negative 120 degrees. So you negative 90 and then 30, which is the exact same point. So the formula to find the exact same point of a coordinate, sorry, let me erase all this first. Delete. So we have something like 2 comma 60 degrees. The same formula would just basically be there's 2 of them. You have the 2, so the radius is gonna stay the same. If the radius is gonna be the same, then it's gonna be the 60 degrees plus or minus 360 degrees n. So n would just be like a natural number. So n could be equal to 0, 1, 2, 3. It just has, it can't be like 2.5, okay? So it's gonna be like 1, 2, 3, 4, 5, basically. Or it could be like an integer. But since this is plus or minus, it kind of negates that. So you could like plus 360 plus 720 plus 1080. Because this is just 360 times 2. This is 360 times 3. So you could keep going that. And you could keep adding those. So you could add 360, add 720, add 1080. Or you could like subtract 360, subtract 720, and subtract 1080. So that's basically the first equation. So it'll be like 60 plus the 360 for 20. 60 plus like 720 is 780. Or like 60 minus 360 is negative 300. Or like 60 minus 720 would be like negative 660. So basically like the same point. It's just that it's like a circle, so it makes like a full rotation and goes back to that point. So it's something like let's say you have a point like right here, and then it goes like a complete circle, and then gets back. So basically what it does is that the first point goes like this, and then it goes back a complete circle from there, and it's the exact same point. So it's just like an overlap. I just drew it above so it looks easier. What it usually does is like this, and it makes and the exact same point. Or if it's like going by negative degrees is, you go back to that point, and then you go negative. So you start from that point again, and then go back around, and then you make a complete circle. See? The circle looks bad because I'm drawing it, but basically that's how it looks. The second equation would be like if it's the negative version. So if negative 2, it would be 60 degrees, the original degrees, plus or minus 180 degrees, and then plus or minus 360. And right? Because think about it, if you have a point like right here, sorry, if you have a point like right here, then you're gonna have to go to the negative side. So you're gonna go to negative right here, because instead of like because you have to like your part is gonna start here, and then you guys go to the positive, right? So you let's say 2 to negative to 60 degrees, basically. Um, what you're gonna have to do is now let's say it's flipped over, so now it's in here that's beginning, and then it has to go to that 180 because that 180 right here goes to that 180 to the back to the original position, and then goes back to that 60 degrees, that original. So that's how you visualize it. Or if you have minus 180, right? But you have to plus that 60. So now instead of going this direction, basically it's gonna go this direction. Goes all the way up here to 180, negative 180. So go back to this position again, the start position, and then you have to add that 60. So it goes back up this way. Goes back, sorry, goes back up to that coordinate right here. So that's how you like visualize it basically. So that's how it works for polar. So I don't know why polar exists. Like it's just there. Like I guess it helps it easier to like graph points other than using rectangular, because sometimes because basically functions for I mean not functions, graph for polar are not functions. So sometimes they look really weird. So they can make something like this. So it's not really a function because it does not pass the vertical line test. So I guess that's a different way to write it. So that's the purpose. Um, Another thing that you should learn, basically from you can screenshot this if you want to find like multiple ways, but usually I just use the most simple one, which is just 2 in the positive version of that angle, the smallest positive. So if they give me like uh 2 and like negative 150 degrees, well, I usually write it as is 2 180 plus negative 150 plus 360, so it gets me 210, and that's why I write it as, because I want a positive angle. So it's just easier to like keep track in my head. Um, and also in this class, starting from now on, we're gonna stop using degreeses, because you say this at 60 degrees. Instead, we're gonna use something called radians. So what we do in this class, what is degrees is basically if you have a circle, right, and you say you have a point right here, and you make a triangle, you say it's like 60 degrees. With this theta, it will say this is 60 degrees, right? But now instead of using basically this triangle to represent this part of the circle, right? This entire part of the circle. Now we're gonna instead of using this, we're gonna use the circumference. Because you see how the circumference basically uses that entire part. The circumference goes around, so you can always use the circumference. So instead of using degreeses to like, which is a concept we made up for triangles, we're gonna use something with the circumference. So let's say we have a radius with a circle with radius 1, right? So basically, a circle with radius 1, the circumference of a circle is 2 pi radius, right? The circumference. So now if the radius is 1, the circumference is 2 pi. That's why usually when they are asking something, it's gonna be called radians are gonna be out of 2 pi. And degrees are gonna be the total amount of degrees in a circle is 360 degrees. Like it's a property of that, so I can't prove it. But it's basically just the entire circle. And then the radians is 2 pi radians, how you refer to it. So it would be 360 degrees at the circle on top is degrees, and then you have 2 pi radians. Okay, 2 pi radians is not the same thing as 2 radians. Okay, do not ever forget it, because basically pi matters. Pi is like a number. It's 3.14159265, etc. But like I don't know the entire digits, but basically pi it matters. So it's gonna be 2 pi radians because it's gonna be measuring the circumference. So from now on, we're gonna actually start using radians instead of degrees, because that's we're gonna like start prepping you for like calculus, because they're never gonna use like basically degrees unless like they really need to for calculus. So for radians, that's what they're gonna be using the entire time, and that's what we're gonna be using in this class, but not as often because this is probably one of the only units where we're gonna teach. Probably the only one that we're gonna use it on. So to use this, we would basically just use proportions. So we have 60 degrees is right. To convert that to like radians, since we know 2 pi radians is one circle and 360 degrees is one circle, we just say 2 pi radians. Sorry. radians divided by 360 degrees. Because they're basically the same thing. So 60 divided by 360 is basically 6. So 2 divided by 6 is 3. So 60 degrees is the same thing as pi over 3 radians. This pi. I'm sorry I read it like a block, but it's a pi symbol. So pi, basically. So this would be p. So 60 degrees would be the same thing as pi over 3 radians. So whatever your let me erase this. So basically, whatever your degrees is, let's say your degrees is, let's say the variable x, then you just need to write 2 pi over 360, and you just do the conversion, and you find the radian measure. It's basically just that simple. Just the degrees times 2 pi over 360. So that's what we're gonna be using this entire time. Um, So going back to the concept of the circle with one radius, it has a specific name. It's called the unit circle. So basically, the unit circle is, let's say, we have the regular plane, right? Not the polar plane, but the regular one. It's going to be a circle with radius 1. So this is 1, this is 1, this is negative 1, and, sorry, that 1, 1, negative 1, and negative 1, right? So basically, for the unit circle, what the courses usually tell you to memorize is like types of triangles. So there's only 2 type of triangles you have to memorize. You need to know the 30 degree, 60 degree, 90 degree, and you need to know the 45, 45, 90 degree. So these are just the 3 angle measures. So the side length here would be like 30, 60, and then you have a right triangle. They're all right triangles. So these are the only 2 triangles you're gonna be learning, and you're gonna have the 45, 45. Sorry, my picture's bad. And then 90. Okay. So basically, what you need to know for these triangles is that let's say you have a 30, you have a 60, and you have the 90 triangle, right? If this is radius 1, then the opposite side, the 30, the smaller angle would be half of that. So it would be 1/2. And the 60 degree would be square root 3 over 2. Okay? You just need to know it, okay? You just need to know it. So it's just one of the concepts you have to memorize in pre-calculus. For 45 degrees and 45 degrees, since you notice that it's both isosceles and it's radius 1, right, for the hypotenuse, then basically, because the circle is radius 1, because if you go like this, then this is going to be a radius because it's a circle, so radius 1, basically. So if this is 45 and this is 45, these 2 side lengths have to be same. So it's going to be the same, it's square root 2 over 2, and this one square root 2 over 2. You basically just need to memorize it. So what they're going to do is that they're going to make you memorize the unit circle. So in the unit circle, there is 8 of these triangles and 4 of these triangles. So what they do is they have a 30-60 triangle right here. So you have a 30 degrees, and then they're gonna make another triangle right here that's a 45 degrees, right? 30 degrees. Remember that where it's placed, because I don't want to draw over it. And then they have here to make the 45 degrees, and then they're gonna go a little bit more, and to make the 60 degrees, right? And then they're gonna loop to this side. So basically, but imagine like you make an angle like right here. So it's this angle right here. But I'm just gonna draw a triangle this side so it's easier. So it's that 90 degree right here. So you also need to know the 90 degree. So you're gonna have the 0 degree, the 90 degree, the 180 degree, the 270 degree, and this is the 360. The 360 degree is the same thing as the 0 degree, so you don't have to worry too much about it. So you can see it. So the 90 degree is just 0, 1. The 0 degree and the 360 degree is just 1, 0 in rectangular form, in the regular plane. And then here is like 0, negative 1, and right here is negative 1, 0, basically. So you can see a bunch of these tables in like the Google Images if you type in the unit circle. So basically, you just gotta memorize it. But it's basically, you just need to know these two circles. So you have the 30 degrees, the 45 degrees, the 60 degrees, and then you can have another one right here, which makes a triangle right here. And this will make the 120 degree. This is this angle, right? And then you're gonna make another angle right here, which is the 135 degree. Because the previous one, the 120 degree, right? It was 120 degree. Then this one is 60. If this is 145 degree, 135 degree, this is 45 because you gotta remember they're 35, 30. Because they're switching between the 30 and the 60 degrees. That's why they have the same angle, but they're just switching the signs. So basically, and then after that you have the 150 degree because this is 30 degrees, and they keep doing that around the circle. So now this, you have a circle right here, so you make a triangle. So imagine you're going like this much. So you have 180 degrees plus that 30 degrees, which is 210, right? But basically, you're just going to have a 30 degrees right here, like 30 degrees. And they keep doing that, like they have a 45 and then a 60 and then another 30, a 45 and a 60, like right here. So you kind of have like, sorry, oops. So they kind of have a 45 right here, a 45 right here, a 45 right here, and a 45 right here. They have a 30, 30, 60. So this would be the 30, this would be the 60. This would be the 30, this would be the 60. This would be the 30, this would be 60. And this would be the 30, and this would be the 60. So if you draw like a triangle, so this would be the 30, this would be the 60, basically. So, and then they're gonna make a 60 degree. So if they have something like this and then goes down, and then this would be the 60 degrees, and this would be the 30. So they have one here, one here. It's basically the 30-60, but now it's the 60-30. It's basically the same triangle. They're just rotating where their angles are. So then you have a 60 right there. You have a 60 right here, and you have a Sorry, I don't know why I drew this one so close. So this one was supposed to be right here. This would be the 30, the 60 would be right here, and then you're gonna have another 60 right here, basically. So like that and like that, basically 60s. So that's how the unit circle will look like. You just have to memorize the coordinates. So basically, let's say you have like right here a 60 degree, a 30 degree. So you have a radius of 1. So since this is the first quadrant, this is positive, right? So this is positive. Oh, this is positive. So 60 degrees, remember, is square root 3 over 2. And this is 1/2. So that's how you get the 60-degree triangle. And so if you have a coordinate in like polar and you say 160 degrees, basically that's what you're going to do. You have a 60 degree, you have 1, and then you have like square root 3 over here. That's 30 degrees. So that's 1/2. And another would be like if you have it like right here, and this is like over here is like 100 and sorry, let me just do a different case. Let's say right here. When we say this is 150 degrees, this entire thing, so this is 30, and this is 60, so this is 1. So opposite of the 30 is 1/2, because the y coordinate in the second quadrant is positive, and the x coordinate in the second quadrant is negative. So this would be negative square root 3 over 2. You just gotta memorize these kind of triangles, you know. And you have something like, let's just say like down here. So that's like a 45. This is a 45, and that's a 90. But it's gotta be the 180 right here plus that 45. So it's gonna be a 225-degree angle. So if this is like radius like 2, right? I mean not radius 2, radius 1. If this radius 1 and this is a 225, it would be 225-degree in polar. So what you're gonna write is that you're gonna write this. You're gonna write, since this is negative right here, this third quadrant, so it's negative square root 2 over 2. And this one right here is also negative, it's third quadrant, negative square root 2 over 2. And those are the two coordinates to get this, basically. So that'll be the coordinate right here, this point right here. So that will get like the coordinates of that. So basically this would be referred to as the unit circle. This has a radius of 1, so it's called the unit, and it's a circle, hence the name, basically. So those are the concepts that you need to know for polar, the introduction. So in this video, we introduced the idea of polar coordinates and make the conversions between like the rectangular coordinates is the x and y coordinates. So we made the conversion from sorry, made the conversion from x, y to radius theta, and we also learned what radius theta is as polar, and we learned how to put this in different ways, radius theta in different ways. So plus the 360 and the minus 360, or if it was negative radius. And we also learned how the idea of radians instead of degrees is. So now we could do conversions between radians and degrees. And we also learned about the unit circle. The unit circle is just more about memorizing those type of triangles. Um, the unit circle isn't really that important. What is really important about the unit circle is that you gotta memorize the triangles of those circles. So you gotta know your 30-degree, 60-degree, 90-degree, and your 45, 45, and 90. You gotta memorize it. Because what's most important about the 30 and 60 is that the opposite of the hypotenuse, the opposite side of the 30-degree angle is a half. The opposite side of 60 degrees is always square root 3 over 2. And then, depending on which quadrant it is, it's gonna be positive or negative. And then the 45 degree is just square root 2 over 2, square root 2 over 2, because they're the same angle. And depending what quadrant, like 30, 60, 90, is positive or negative. So you just have to memorize those coordinates, because you're going to be using that a lot. Because those are the only like coordinates that we usually do. Because there are other triangles that we could get radicals of to get their side length, but to like get not decimals. But basically, we're not gonna do that for use those. Those are the two main cases: the 45, 45, 90, and the 30, 60, 90. Anyways, thanks for watching, and I'll see you at the next math record.